So just like solving one-step inequalities, we're going to be solving multi-step now, just like multi-step equations, where there's going to be steps for solving. It's like last night's homework was only one step, you only had to do one thing in order to solve the equation. Now you're going to have to do multiple things, so it's called multi-step. The steps for solving multi-step inequalities is extremely similar to multi-step equations. So you have to distribute first, then multiply by the LCD to eliminate fractions, combine like terms on the same side of the inequality instead of equal sign. We are going to add or subtract to move the variable to one side. I highly suggest it whenever possible to move your variable to the left, because it makes it easier when graphing them, okay? Because then your arrow is pointing in the right direction, there's no confusion, okay? If all variables cancel out, it is a special case. So remember that if the variables canceled out and it created a true statement beforehand, like for example 2 equals 2, that was all real numbers. And so in this case, if we have something that is a true statement, it's also going to be all real numbers. If it's not a true statement, then it's going to be no solution. Then we're going to add or subtract to move the constant to the other side. And then we're going to multiply or divide to get the variable by itself. If you multiply or divide by a negative number, you reverse the inequality sign, just like we did in our one-step equations. Inequalities, sorry. So in order to solve this equation or inequality, I'm going to add 5 to both sides. So I'm going to get 2y is less than 7 plus 5 is 7 plus 5? 12. Divide by 2. Am I dividing by a negative number? No, so I'm going to keep my inequality sign the same. And 12 divided by 2 is 6. So it's just like solving equations, except for with that one little extra, if it's dividing by a negative number. So normally, if we were solving this as like a normal equation, I would subtract the 2 normally because it's a smaller one. However, it's going to make it harder for me to graph my inequality because you still have to graph these ones. I'm just not going to waste time. I'm not going to graph them on here because we spent so much time yesterday graphing these. So I feel like you guys know how to do that. So, but in order for me to graph this, I would have to have it on the left. My variable needs to be on the left side. And if I subtract my 2, my variable is going to be on my right side, then I'm going to have to rewrite it, and you might make a mistake when rewriting it. So if I suggest moving it to the left side, okay? So I'm going to subtract 4x from both sides. I'm going to get negative 2x minus 4 is greater than or equal to negative 1. Add 4x to both sides. Negative 2x is greater than or equal to 3. Okay, now I'm going to divide by a negative number. So what happens when I divide by a negative number? I flip the sign. I reverse the sign. So it's going to become less than or equal to. And then I'm going to have x and just negative 3 over 2. And then I can graph this. My arrow would be pointing to the left. So if I did the other way, then I'd have to rewrite this when I got to the end, which you'd still get the same answer, just you're more likely to make a mistake. That's what I worry about. Alright, so I have parentheses, so I need to distribute. So I'm going to distribute my 2. So I'm going to get 2x minus 16, which is greater than negative x plus 4. I'm going to subtract 2x from both sides. So I'm going to get negative 3x plus 4 is less than negative 16. Subtract 4 from both sides. Negative 3x is less than negative 20. And then we're going to divide by negative 3. So we're dividing by a negative number, so what do I have to do? Change the sign, or flip the sign, so it's going to become greater than. So x is going to be greater than, I have negative negative, so it's going to be 20 over 3, positive. And then if I was graphing this, I would just divide 20 by 3 and see where it would be on my number line. Okay? Okay, I have parentheses, so I need to distribute. I'm going to distribute the negative sign. So I'm going to get 3 minus x minus 1 is less than or equal to 2 plus 4 minus x. My next step is to eliminate fractions. I don't have any fractions. My next step is to combine like terms on the same side of the inequality. So 3 minus 1 is 2. And 2 plus 4 is 6. I'm going to add x to both sides. And I'm going to get 2 is less than or equal to 6. And those cancel out, those cancel out. So is 2 less than or equal to 6? Is that a true statement? Is 2 less than 6? 2 is not less than 6? 2 is less than 6. So is that a true statement? Yeah. So this means it's going to be all real numbers. Remember that's like that double R? Or double lined R, which stands for all real numbers. Okay, so I have parentheses, so that means I need to distribute. So negative 2x plus 1 is greater than or equal to 3x minus 24. Then, once I distribute, do I have fractions? No. Do I have like terms on the same side of the equal sign, or inequality sign? No. So I need to isolate my variable. So I'm just going to move it to the left because it makes it easier when graphing. And you need to have it on the left. I'm going to get negative 5x plus 1 is greater than or equal to negative 24. I'm going to subtract 1 from both sides. I'll put negative 5x is greater than or equal to negative 25. Then I'm going to divide by negative 5. So I'm dividing by a negative number. So what do I need to do? Change the sign. Flip it. Or reverse it. So I'm going to x, and then I have negative 25 divided by 5. Negative 5. Which is what? Positive 5. And then, so my arrow would be pointing to the left when graphing. Okay, so do I have parentheses? No. Do I have fractions?
Yep.
Yes, so I need to multiply by my least common denominator. So it's usually your largest denominator, so 6. So I'm going to get 2x minus 3 is less than or equal to 5x. So this is one of the cases that I can't really lose my x because then I'm going to be left with nothing on that side. I mean, I technically could. I have 0 here, so I guess I can do that. So I'm going to get negative 3x minus 3 is less than or equal to 0. And I'd have to add 3 to both sides. So negative 3x is less than or equal to 3. Then I'm going to divide by a negative number. What happens when we divide by a negative number? Flip the sign, right? So I'm going to get x, and what's 3 divided by negative 3? Negative 1.
Oh, 3.
And then our arrow would be pointing to the right when graphing. And this would be a closed circle. So what is my first step? Distribute. So
More stuff.
I'm going to distribute my negative sign and my 2. That means I'm going to have 17 minus 4k plus 2 is greater than or equal to 2k plus 6. So then I have to, do I have fractions? No. So what do I need to do next?
Like, big ones, like,
Combine.
like,
Combine like terms, 17 plus 2. We're not isolating our variable until after we combine like terms. Now I can isolate my variable. I move my variable to one side.
Yeah.
So make negative 6k plus 19 is greater than or equal to 6 minus 19. So negative 6k is greater than or equal to what? What's 6 minus 19?
13.
Okay.
Negative 13.
Instead of your turn, you guys should be doing this one on your own. And I'm going to divide by negative 6. So what do I have to do with my sign?
Switch it.
Switch it. So I'm going to make it less than or equal to. So I'm going to make k is less than or equal to, and I have negative negative. So it's going to become a positive 13 over 6. And then when we graph it, you could just divide and then figure out where that would be on your number line. However, I want our answers in our fractions. Okay, what is my first step here? Do I have parentheses? What about fractions?
No.
Do I have like terms? Yes. 7y minus y is 6y. Subtract 6y from both sides. So I'll get 8 is greater than 2. Is 8 greater than 2? Yeah, that's a true statement.
Oh, yeah.
So that means that it's all real numbers. Or identity. And then we have 2 word problems. Okay, you have $18.50 to spend on pizza. It costs $14 for a large pizza plus 70 cents for each additional topping. How many toppings can you possibly afford to buy? So we don't have to spend all $18.50, it's just how much money I do have. So I need to write up my equation. So I need my order to be, less than or equal to $18.50, right? And my base cost is $14. And how much is it per topping? 75 cents per X, or whatever variable you like to use. So now I can solve. I'm going to subtract 14 from both sides. So that means I'm going to have 0.75 X is less than or equal to what? What's 18 minus 1850 minus 14? $4.50. And then I'm going to divide by 0.75. And what is 450 divided by 0.75? 6. So at most, I can have 6 toppings. No more than 6 toppings. Somebody in my first grade thought that was a lot of toppings. But I eat veggie pizzas and they have more than 6 toppings on them. Yeah.
I ate all of them.
Like olives, onions.
I have one pizza. That's expensive. You need to get out of life right now.
I get it every
Okay,
Fish.
sorry, I shouldn't have gotten Alright, do one more slide, then you guys can talk, unless you're taking a test. Your test grades are 88%, 93%, and 86%. What must you get on your fourth test to have an A for the class? A's are given for 96 and above. So I need to have my average should be greater than or equal to 90%, because I want to have an A. To find the average of something, what do? We add them all up and we divide by how many there are. So I'm going to take 88 plus 93 plus 86 plus my X, because I'm taking a fourth test. And so this is 4 things that I'm going to be dividing by. I need to combine like terms, so I'm going to add 88 plus 93 plus 86. And I'll get 267. I'm going to eliminate my fraction by multiplying by 4. I don't know why I put 90%. So my 4's here cancel out. I'm left with 267 plus X. And what is 90 times 4?
That's a big number.
360. We're going to subtract 267 from both sides. So X is going to have to be greater than or equal to what? What's 360 minus 267? What? 93. So she needs to get at least, or he, at least a 93. %.